So now we're going to do a couple of tricky power series representations. So let's start off with one problem. So let's say we wanted to find the power series representation for this function. So let's say we were looking at 1 over 1 plus x squared. Okay. So for this particular problem, let's not worry about the interval of convergence. Let's just go ahead and find a power series representation. So we know that 1 over 1 minus x is equal to the sum from n goes from 0 to infinity of x to the power of n. Okay, this is what we have figured out. So now we don't quite have one for squared. If I try to FOIL everything out on the denominator, it'll not be nice. So one thing that I can probably do is I can have 1 over 1 plus x squared, or 1 minus 1, 1 over 1 plus x, okay? So I know what that guy is because I can rewrite this as 1 over 1 minus negative x, okay? So I can go ahead and do this. So I'm going to have the sum from n goes from 0 to infinity. I'm going to plug in this negative x into this x. And what I'm going to get is the sum from n goes from 0 to infinity of negative 1 to the n, x to the power of n. So I know that the power series representation of 1 over 1 plus x is going to be the sum from n goes from 0 to infinity of negative 1 to the n, x to the n. So that's what I do know, okay? So now, how am I going to get from here to here? Well, this is what I'm going to do. This is where the trick comes in. What I'm going to do is I'm going to take the derivative to both sides. Okay, well, if I want to take the derivative of this, I can always write it as d over dx of 1 plus x to the negative 1. Okay, the derivative of this thing, d over dx, well, that's just taking the derivative of x to the power of n. So let me erase that. So summation n equals 0 to infinity, negative 1 to the n. Take the derivative of this guy, bring in the n, x to the n minus 1. Okay, so now what you're going to have, let's take the derivative of this other part. So that's going to be negative 1, 1 plus x to the negative 2. Okay, and this is equal to the sum from n goes from 0 to infinity, negative 1 to the n, and x to the n minus 1. Okay, notice that I can just rewrite this as negative 1 over 1 plus x total quantity squared is equal to the sum from n goes from 0 to infinity of negative 1n and x n minus 1. Okay, so notice that now I kind of have everything because this thing is basically what I wanted to figure out. Let me get rid of that negative though. When I get rid of that negative, I'm going to have 1 over 1 plus x whole quantity squared equals the negative sum from n equals 0 to infinity, negative 1 to the n, and x to the n minus 1. This negative is just going to be the sum from n goes from 0 to infinity. This negative is just basically a 1, negative 1 to the power of 1, negative 1 to the power of n, and x to the n minus 1. So when I complete this, I'm going to have negative 1 to the power of n plus 1, and x n minus 1. So this thing is a power series representation of this particular series. So you had to do a little bit of a trick doing this derivative thing to both sides to be able to get that. And the reason why I thought about it was because you can see that the derivative of this thing is just to the power of 2. Okay, so doing that can get you this particular part. Now this is a suitable answer. This is correct. Now notice that when I plug in 0, you do get a 0 on the on here. So usually one of the things that you might want to do is change the indices. But this is correct. This is still a good answer. Let's try one more problem. Let's say you wanted to find a power series representation of ln of 1 minus x, or 1 plus x. Okay. So now, if you look at this, there's no way that we can get a natural log from 1 over 1 minus x because natural log is a different function from 1 over 1 minus x. But we do know that there is that the derivative or the integral of 1 over x is just going to be a natural log. So maybe how we did it here with a derivative, maybe we can do it with an integral. Okay? So notice that I have a 1 over 1 minus x. We know that this is the sum from n goes from 0 to infinity of x to the n. Now we don't want 1 minus x, we have a 1 plus x. So I'm going to write 1 over 1 plus x. Well, we just figured that out. It's from n equals 0 to infinity, negative 1 to the n, x to the n. So we just figured that out. Okay, so what I'm going to do is that I have to somehow come up with the natural log. So one way that I can do it is just taking the integral to both sides. So I'm going to have the integral from 1 over 1 plus x dx is equal to the integral of the sum from n equals 0 to infinity, negative 1 to the n, x to the n, dx. Okay? This guy right here, you can do u substitution. You'll see that you get ln of absolute value of 1 plus x, which is just what we wanted. Okay, notice that we have that. And on the other side, notice that the only thing that we really care about is the x value, because that's being we're doing the integral with respect to x. So I can take the sum out, and I can take that negative 1 outside as well. And all I'm left with is just the integral of x to the n, which is just going to be x to the n plus 1 over n plus 1 plus c. Okay? All right, so now we're almost done with this. Okay, the only thing that we need to figure out is what exactly is this c. So now what you would want to do is plug in some value for x. The easiest number to plug in for x is just 0. That I think is the easiest number. So ln of 1 plus 0 is equal to the sum from n equals 0 to infinity, negative 1 to the n, and then this is just going to give me 0 plus c. So I have ln of 1 is equal to the sum from n equals 0 to infinity of 0 plus c. Here just summing a whole bunch of zeros. So this is going to be 0. This thing is going to be 0. So c equals 0. Okay, so don't feel very comfortable with this being 0. It's not always going to happen, but it did in this case. So all we have to do is that we go back to this guy. So ln of 1 plus x, okay, is going to be equal to the sum from n goes from 0 to infinity of negative 1 to the n, x n plus 1 over n plus 1. And then plus 0. But since we knew that c was equal to 0, then we don't need to write it out. Okay, so this is basically going to be our final answer. Don't worry so much about the absolute values, and obviously you can find the radius of convergence as well.